All right, let's see what we have for today. We are entering into remainder theorem on the polynomials on the elementary algebra. Okay, we want to treat remainder theorem. Now let's take this question. Find the value of k if the remainder when p of x, which is 2x raised to the power 4 plus kx raised to the power 3 minus 11x raised to the power 2 plus 4x plus 12 is divided by x minus 3 is 60. Okay, now we are asked to find the value of k, that when this 2x raised to the power 4 plus k x raised to the power 3 minus 11x raised to the power 2 plus 4x plus 12, when it is divided by x minus 3, you will have remainder 60. But we are not given the quotient, but we are asked to find the value of k. Hello. Good. Now let's go. This question, I want you to pay attention to what we are going to do. We have our divisor to be what? X minus 3. So I want you to equate our division equal to 0. Equate it to 0. So we are going to have x minus 3 is equal to 0. Make x the subject. So x is equal to what? 3. X is equal to what? 3. So as x is 3, in our function or in our dividend, wherever we see x, we are going to replace it with what? 3. So here we are going to say p of 3 is equal to 60. That is, p of 3 is equal to our remainder, which is 60. Now let's go. We are going to say p of 3 is equal to, in our dividend, we are having 2x raised to the power 4. So we are going to replace it with, we are going to replace x with what? With 3. So we are going to have 2, open bracket, 3 raised to the power 4 plus k. We are having x to replace it. We have open bracket, 3 raised to the power 3 minus 11, open bracket, 3 raised to the power 2 plus 4, open bracket, 3 plus 12 is equal to our remainder 60. Okay, now let's solve. We have 2 in bracket 3 raised to the power 4. It will give us 3 times 3 times 3 times 3. That is 3 times 3, 9. 9 times 3, 27. 27 times 3, that is 81. So we are having 81. When 3 is raised to the power 4, we have 81. Okay, now plus k in bracket 3 raised to the power 3 will give us 27. Okay, then we have k open bracket 27 minus 11. 3 raised to the power 2 will give us 9. That is 3 times 39. Okay, now plus 4 times 3 will give us 12. Plus 12 is equal to 60. Now let's go. We have 2 times 81 will give us 162. Plus k times 27 will give us 27k. Minus 11 times 9 will give us 99. Plus 12 plus 12 will give us 24. Is equal to our remainder 60. Okay, now let's go. We are going to say 162 minus 99. I think it will give us 63. Then we have plus 24. Then plus 27k is equal to our remainder 60. Okay, now let's go. We have 63 plus 24. 63 plus 24. What will it give us? It will give us 87 plus 27k is equal to our remainder 60. Okay, now let's go. Let's make 27k the subject. We are looking for k, right? So we are going to have 27k is equal to, we have 60. We take 87 from the left hand side to the right hand side. So as 87, which is positive, is crossing the sign of inequality, it will change to what? Negative. So we have 27k is equal to 60 minus 87. Hope you understand this, right? Good. Now we're going to say 27k is equal to 60 minus 87 will give us minus 27. Okay, so we are having 27k is equal to minus 27. So we are looking for k. So we are going to divide both sides by 27. Divide both sides by 27. So we have 27k divided by 27 is equal to minus 27 divided by 27. So 27 cancels 27 in the left hand side. We are going to have k, and then minus 27 divided by 27 will give us minus 1. So our value k is equal to minus 1. Our value k is equal to minus 1. Okay, so therefore, the function, when we replace k for 1, we are going to have 2x raised to power 4 minus x raised to power 3 minus 11x raised to power 2 plus 4x plus 12. That is the main function that is given to us. All right, thank you very much. Let's treat more examples on this remainder theorem. Example number 2.